Bismillah ar-Rahman ar-Rahim. In this lecture, I am going to teach you the feasibility of redox reactions through formal reduction potential values or the biological oxidations. So let's move to the lecture. This is the article, my own article. I will share you and upload on the Moodle. So what we are going to study here, actually, what is the formal redox potential values, because simply you can understand these are the value at the laboratory scale, because where we are not going to use the unit concentration of the metal ions or the hydrogens or the hydroxyl ions, or where the pressure is not 1 atmosphere, where temperature is not 25 degrees centigrade. So at the laboratory conditions, actually, these are the real conditions in which we are working or doing research in our laboratories. So here the potential is very important. That means the actually potential within the solution is very important, and this is going to influence the redox reactions. So in this lecture, I will teach you two major concepts. One is we will look on why the same metal ions having the different redox potential values when it is bonded with the different ligands. And the second objective is why the potential is going to vary in different medium, and specifically we will discuss the acidic medium. So these are very important 2 points, and let's move to the first one. So these are as a reference. I have mentioned three of the half cells over here, and again, just have a confidence, and you can do this all the rest of the metal ions if you understand this lecture as well. So what is the similarity in these three half cells? So if you look at the first one, this is the iron plus 3 accepting 1 electron, and then it is converted into the iron plus 2. So this is the reduction. This is the oxidized form. This is the reduced form. And of course, all these three are the oxidized form of the iron. All these three are the reduced form of the iron. So the similarity is in all these three forms, iron plus 3 is there. Oxidation state of iron is also plus 3. Oxidation state of iron is also plus 3 in case of the number 2, number 3, and of course in number 1. So this is the bare, we call it the bare iron. This is the iron bonded with the cyanide. This is the iron bonded with the phenolphthalein, and these are the two ligands. So the iron having the same plus 3 state, accepting 1 electron, and it is converted into the iron plus 2 state. So oxidized form is same and reduced form is the same. So what I am going to teach you over here, if you look at the redox potential values, these are not the same. So that is the reduction of iron plus 3 to plus 2 state is happening in all three steps, but the oxidation potential is not the same. I hope you have gotten my point. So this I am going to teach you that actually what is happening over here, and then we will use this knowledge to apply to clear our second objective. So let's move to this is the bare metal iron metals, and its potential is 0.771. And in case of the iron cyanide complex, so the potential is 0.358. That means it is less as compared to the 0.358. So what do you learn about if the potential is less as compared to the other one, or the potential is more, like in case of the half cell 3 as compared to the number 1. So we are using the first half cell as a reference, and then there are the two examples. And second is having the potential which is less than as compared to 1, and third one having the potential which is more than as compared to 1. So let's first discuss the half cell, which is mentioned at serial number 2. So why the potential is less? So the first is, what do you understand if the potential is less? So that means if the potential is less, that means this is having the less ability to reduce to form the iron plus 2 as compared to the serial number 1, where it is the bare hydrogen, iron metal ions are converted into the iron plus 2 ions. So, or you can say this is the potential of 1 is more than as compared to 2. That means this bare element metal ion is easily converted into the plus 2 state. So the more potential value mean more reduction potential. That means it is having the more strong forces to accept the electron. That's why it is having the more electromotive force or the reduction potential. So in case of the example half cell, which is mentioned at 2, it is having the less potential as compared to the bare element. So its reduction potential is less. That means it is iron cyanide is having the less ability to reduce to the iron plus 2 cyanide complex as compared to the reference bare element. So this is the understanding. That means what does it mean by the less or the reduction potential less or high? So why it is happening? So what is happening with the cyanide? Actually, when the cyanide is complexed with the iron and complexed with iron plus 3 and plus 2, that means again there is the competition of stability between the F3 state and the F2 state. So reduction potential is less. That means iron cyanide 6 plus 3 complex, that means oxidized form, is having the less ability to reduce to this form. That means iron plus 2, iron plus 3 cyanide complex is more stable as compared to the iron plus 2 cyanide complexes. That's why its reduction potential is less as compared to the bare element. So let's move to the third one. This is having the more reduction potential as compared to the bare. That means this oxidized form is more easily reduced to the iron plus 2 phenanthrene state, because now this stability of iron 3 phenanthrene, which is at the oxidized form, is less stable as compared to the iron plus 2 phenanthrene complex. That's why it is easily converted into the, or easily reduced into the iron plus 2 phenanthrene. So this is all about the, if you just to compare with the standard oxidation state, that means in the all three example, the metal oxidation is same in all three half cell, but having the different redox potential values. And of the reason is already explained over here. You can also read the statement, what I have explained to you. So moving to the other objective. So let's suppose I'm going to discuss the example of the bare element. The standard reduction potential is 0.771. So what is the learning point over here? If you prepare these metal ions in different acidic medium, that's what this is the perchloric acid, hydrochloric acid, nitric acid, sulfuric acid, or phosphoric acid. So its reduction potential is also going to be varied. So in case of the perchloric acid, it is less as compared to the standard oxidation potential, which is 0.771. So in the presence of the perchloric acid, and this potential we call it the formal potential, because this we have calculated at the laboratory scales and in the presence of the perchloric acid medium. So 0.771 is the standard and 0.737 is the formal potential. All these are the formal potentials. So what is happening here? So the interesting thing is when you change the acid, the potential is also going to vary. So it is more in the presence of the perchloric acid and it is least in the presence of the phosphoric acid. So again, it is again very interesting. That means as a chemist, you can also change the potential is, and if the potential is changed, you can also change the spontaneity of the reactions. So let's solve the reason. What is the reason behind this one? So again, as I have explained before, now what is happening here? These perchlorate, chloride, nitrate, sulfate, or the phosphate ion are going to interact with the positive ions of the metals, iron metal, which is iron plus 3 or iron plus 2, oxidize and the reduced form, because these both are present in the solution. So that means just the first is it is less as compared to the standard oxidation state. That means because the iron plus 3 state is more stable in the presence of these anions, because they are going to have a complex with the iron plus 3. That's why iron plus 3 is more stable as compared to iron plus 2 in the presence of these ions. That's why its reduction potential is less as compared to the standard reduction potential value, which is 0.771. So one thing is clear. Now moving to the second point, why it is going to vary with these different anions or the acid strength. So that means it is more in the presence of the perchlorate and it is least in the presence of the phosphate ions. So that means phosphate ion having more bonding or the more strong interaction with the iron plus 3 ion. So its stability in the presence of the phosphate, stability of the iron plus 3 in the presence of the phosphate ion is more. So that's why it is more stable, having less ability to reduce to the iron plus 2 states. That's why its reduction potential is less as compared to the other ion. And the same reason is for the rest of the ions. You can compare any of the ions with the same reason. So this is all about the variation of the formal potentials in the presence of the different medium. And we also call it the biological oxidation, because the iron is present in the hemoglobin. So if there is let's suppose you take different salts or different anions, so they are going to interact with the metal ions. If there is the chances to form the complex, because it depends on the the body or the system which is present in the body to form the complexes or not. So this is the all about the variation of the formal potential with the in the presence of different medium. So see you in the next lecture. Thank you.